I'm Chris Pettit. I've been a backend developer for over 2 decades now. Throughout my career, I've worked on a range of products from web-based content management systems, business intelligence systems, and backend systems for mobile apps. Over the past year, I've been focused on migrating to and developing microservice applications on AWS. So today, we're going to be looking at a new feature that debuted at last year's AWS reInvent, and that's EventBridge Pipes. So first, let's look at the current state of event-driven architecture. Okay, event-driven architectures have gained in popularity for their ability to decouple microservices, scale effectively, and provide real-time responsiveness. AWS offers numerous services that support the development of your applications. These services enable the easy creation of microservices with various components handling data throughout its entire lifecycle. For instance, you can use API Gateway or Kinesis for data collecting, SQS or MQ for data queuing, step functions for validation, verification, and processing, DynamoDB for storage, CloudWatch for logging, EventBridge or SNS for event publishing, and Lambdas to host your actual business logic code. But despite their advantages, building event-driven applications can be challenging due to the need for all the intermediate code you need between services. This code filters data, retrieves supplementary data from other sources, and formats data for the target service. This extra code has now introduced new complications in your microservice application. First, you have to understand the nuances of each technology you're integrating with. For example, if you're using Kinesis, you have to use the Kinesis client library and understand how interacting with shards works. But with SQS, you use the AWS SDK, and you have to know the intricacies of consuming messages. With Kinesis, you only have a single consumer per shard, but with SQS, you have multiple consumers per queue. Next, you have to worry about error handling. What will your code do if a message can't be processed correctly? And what happens if you're batching messages and one of them fails? What if you're pulling in data from a third-party API? You'll need to handle the connection and authentication as well as flow and rate control. And finally, you have to maintain the code and handle the deployment. You'll need to make sure that you provision enough resources and capacity to handle any demand you expect to receive. All this leads to a high total cost of ownership as you devote more developer time to maintaining integration code rather than focusing on your core business. And this is where EventBridge Pipes comes in. So what is EventBridge Pipes? Pipes provides a simpler, more consistent, and cost-effective way to create point-to-point integrations between event producers and consumers. By replacing integration code with a service that manages intercommunication, EventBridge Pipes simplifies the process. The concept is inspired by terminal piping, so a long-established software architecture practice. In a terminal, you can chain programs together to manipulate data as needed. For example, you can get a list of files in a directory, filter them based on permissions, sort the data, and write it out to a file, all with just one line of input. EventBridge Pipes follows this concept. When setting up a pipe, you can choose from 6 different input sources, filter your data, use 4 different services to enrich your data, and finally send the output to one of 15 different services. So how does EventBridge Pipes differ from EventBridge buses? Both buses and pipes are features of EventBridge, which enables event-driven architecture. However, they differ in how they handle the events. Buses are pipelines that receive events from various sources and can match events to criteria using rules. Matched events can then be sent to one or more targets. In contrast, pipes are point-to-point integrations that connect a single source to a single target with optional steps for filtering, transformation, and enrichment. The main difference between the two is that buses handle multiple sources and targets, while pipes handle only one source and one target. Buses offer more flexibility and scalability, whereas pipes are simpler and more straightforward. Buses require integration code, while pipes reduce the need for it. Buses can handle various event formats and protocols, while pipes only handle JSON events. And so here's a few examples of how pipes can be used in various scenarios. You can use pipes to filter high-value events from a Kinesis data stream and send them to SNS. You can filter the events that contain a certain keyword or match a certain pattern, and then send them to an SNS topic that triggers a Lambda function or step functions workflow. You can use pipes to enrich events from DynamoDB. You receive events from the DB table that contains the customer ID, and then you use API Gateway endpoint to get the customer information for each order, such as name, address, and payment method. Then you send the enriched events to step function state machine that handles all the order fulfillment logic. So if your event has thin data, say only returning a customer ID, you can call out to a third-party app like Zendesk to get customers' address information, allowing you to keep one single source of truth throughout your whole application. So Pipes comes with several features and benefits that can significantly improve the efficiency and performance of your event-driven application. You can use event filters to select specific events from the source based on a pattern. This will help you to reduce the amount of events that are processed and delivered to the target, saving on cost and improving efficiency. You can retrieve and deliver events in batches, making integrations more efficient. Batching also helps you handle large volumes of events quickly and avoid throttling errors. You can provide guaranteed ordering of events for applications where the ordering is critical. Pipes will maintain the order of events from the source to the target, ensuring that your application receives events in the correct sequence. You can support high concurrency, so you can process large volumes of events quickly. Pipes handles up to 10,000 concurrent invocations per pipe, scaling up and down automatically based on demand. And you can provide enrichment capabilities using Lambda functions, step functions, API gateway, or an API call to a third-party API destination. Enrichment allows you to enhance or transform the events from the source before sending them to the target. As for the benefits of it, you can build fully managed integrations quickly with an easy-to-use interface that connects event producers with consumers. You don't need to write or maintain integration code, such as polling, error handling, or retry logic. You can lower your compute and usage costs by using event filters and built-in integrations. You only process and pay for the events that you need, and you leverage existing integrations, AWS services, and third-party APIs. You can deliver events to 15 AWS services with Pipes seamlessly polling for new events. You can react to events as they happen, enabling real-time responsiveness and performance. And you can reliably connect services without worrying about scalability, security, patching, and provisioning your infrastructure. Pipes handles the underlying infrastructure for you, so you can focus on your business logic. Now, let's look at what makes up a pipe. First is the source. This is the starting point of the pipe. The pipe can receive events from various sources such as SQS, DynamoDB, Kinesis data streams, Apache Kafka, both managed or self-hosted, and EventBridge buses. Next, you can filter your data. This is an optional step that allows you to select a subset of events from the source based on a pattern. You can use filtering to reduce the amount of events that are processed and delivered to the target, saving on cost and improving efficiency. Then we have data enrichment. This is another optional step that allows you to enhance or transform the events from the source before sending them to the target. You can use enrichment to add more data to an event by making an API call to a third party using API destination, or by invoking an AWS service such as Lambda functions, step functions, or API gateway. You can also use enrichment as a filter by returning an empty response if you don't want to invoke the target for a certain event. And then finally, we have the target. This is the endpoint of the pipe. The pipe can send events to 15 AWS services such as SNS, SQS, Kinesis, Lambda, step functions, or other EventBridge buses. Pipes also support optional input transformers when passing data to the enrichment in the target. You can use input transformers to reshape the JSON event input payload to serve the needs of the enrichment or target service. For example, you can use input transformers to map the event fields to the API expected parameters, or to extract only the relevant data from the event. Input transformers are modeled on an input template parameter. They can be free text, a JSON path to the event payload, or a JSON object. For enrichment, the event payload is coming from the source. For targets, the event payload is what is returned from the enrichment if one is configured. Here you can see a transformer to pull only the data we need at the target and to format it into the expected JSON format. Okay, so now I want to go through, and I'm actually going to build out a few pipes, give you a demonstration on the ease of implementation and the actual capabilities of pipes. All right, so the first one I'm going to do is going to be a basic, just hooking up SQS to a step function. Because generally you'd have to pull it into a Lambda, format it, and then send it out to the step function and have that intermediate step. But now all you need to do, so I've already set up I've set up a SQS queue, and I've got a state machine that I've set up, and all it is just a pass state as a placeholder. So all we need to do is go in, hit create pipe. Sorry, my throat's getting messed up. For the source, we'll just hit SQS and select the queue I've got. Okay, we're going to ignore filtering and enrichment for right now. We'll hit both of those in just a minute. And then for the target, we just go to step functions and select that state machine and create. Oh yeah, and you have to put in a pipe name. Like that. And that's it. Your SQS is now hooked up to your state machine. So if I go in to send and receive message, and I just put in a basic object like that, send it. We look at the state machine, check out executions, and there it is. There's our user. So it's that simple just to hook up to services without having to write any code in between them. Okay. Now for the second one, a lot of times, like with e-commerce or just any other app, you'll need to keep certain databases in sync. So say I've got an e-commerce site where I'm taking in orders and I want to keep track of my inventory in another remote database. So I've got this inventory here. What I'm going to do is create a new pipe. And this will be, and for this one, I'm going to pull a DynamoDB stream off the orders table. Just grab the latest on that. Okay, and if let's say I just want to pull in, the events, only if it's a new order. So just on an insert instead of a modify. Okay, so this is an example of what will be returned from the Dynamo string. So I can filter on this event name. So I just put in event name prefix on insert. And so if it's if this is anything but other than insert, it's going to reject it. Go to next. Okay, we'll skip enrichment this time. I just want to pass it to a Lambda. So for target, we're going to pass it to a Lambda function I've written. And it's going to be process items. And all this does is take the order object, grab the items and the quantities, and modify a remote database. So create that. Okay. Usually when you hook into most services, this is instantaneous, but generally I found when hooking into a stream like Dynamo or Kinesis, there's usually a few second to a minute delay. So while we wait on that, let's look at another feature. When you go through the console to create it, you don't have to worry about your IAM roles. The console for pipes will go in and figure out all the actions and resources you need to perform the task you're looking for, and it will go ahead and create that role for you. So you don't even have to worry about it. So we got that set up. And, all right, so, okay, we had the inventory here. So I got everything set to 40 on that. Okay, I'm just going to run an API to a Lambda I've got hooked up. That's just going to run 2 of this and 11 of that. So push that. Okay, and that just sends to a database that sits there. The pipes will grab it and push it, filter it out, push it to a Lambda, and the Lambda will take care of everything. So we update that, and the quantities are there. So you can hook into any remote database or other services you need just to keep things in sync. Okay, now for one last one, and this is something that a couple of you that I've worked with before, we're going to know exactly what I'm talking about. This is going to be pulling data from an external source, from a third party, to enrich data that we've already pulled in. So I've got a cars table here, and all I'm doing with that is just putting in a VIN number. And I want to go to a, sorry about that. I want to go to a third-party API and pull in all the vehicle information from that VIN. When we built this before, it's taken, you have a Lambda that has to go and a way to call and then format all that data. So the easier way to do it now was create a new pipe. Just call this VIN lookup. Okay, the source is going to be another Dynamo stream, and that's going to be off my cars table. All right, next. Okay, we're not going to filter this time. Now for enrichment, we're going to call it API destination, which I've got set up. Okay, API destinations are how you connect to a third-party API. All right, so go with VIN API. Just put in a description, and then you just need the URL for it. Now you'll see with this URL, I've got an asterisk in there, and that's a wildcard that you can populate with event data. And we'll see that in just a second. And you just set up your method, and then you have a connection. This is where you'll set up basically how you authenticate. So if you need to username or OAuth or anything like that, you set it up here. I've already got one set up, so we'll pull that in. Let's try pipes again. Source, Dynamo, cars, next. with that enrichment. Okay, destination. So we'll use that Vent API. Now, as for that wildcard, what we'll do is just put in a path parameter that's going to pull that new image, object out of that Dynamo string, and it's going to grab the VIN number from it, and that's just going to replace that into here. And then, so, okay, with this is the data that's returned from that API. So there's a lot of data that we don't need and just hard to get at. So what we'll do is we'll go to, see, I'm going to write it out to CloudWatch log just so we can see it. And so you have that simple, basically we'll put this in here and it'll take all that data and filter it out to just the data we're looking for. So we'll create that real quick. Okay, and while that's hooking up to that stream, show you a couple of features of this. When you're going into the source, you have these additional settings, and this is where you're going to set your batch sizing. So yeah, you can pull one at a time, or you can batch out and pull in however many you want at a time, just so you have better throughput. Okay, now, so for the cars, I'm going to pull a random VIN number real quick, and we'll just create it. And all I'm putting in here is the VIN number. Yep. So yeah, it takes a little bit of time to hook up to the streams. One more. About one last time. There we go. And just from that VIN number, it's going in and pulled out the data I need and formatted it so I can pass that on to whatever service I'm using. So in conclusion, EventBridge Pipes is going to allow you to more easily implement event-driven architecture while allowing you to focus more on your business and less on supporting intermediate code. So thank you for coming, and I'm going to open it up for any questions you have.
Tell me any war stories about getting up and running with this and getting it to work for the use case, or anything you kind of learned the hard way while you were going through it.
Actually, that's the good thing about this. There's been a lot of services that it takes a lot of ramp up to really learn it, but this it's pretty simple right from the get-go. It's straightforward for what you do. So it was a really quick ramp up time on it. So yeah, there's a lot of ways I saw that it could be used, but yeah, everything I was trying, yeah, I never really had any hard pain points on it. It was one of the quickest ones I picked up so far.
Cool.
Hey, I've got a question.
Okay.
Yeah. So Chris, have you ever tried, I was wondering, that was a cool presentation, by the way. That was really good. Some of that stuff I'd never seen myself. So that was really cool.
Thank you.
Yeah. And I was wondering if you've ever tried the exercise of like translating. I always do what you do. I think probably what everybody does. I do everything through the console first.
Yeah.
And right. And then if I want to translate that into automation, I'll translate that. Then my actions basically, I'll translate that into Terraform or into CloudFormation. But I was wondering if you'd ever tried doing any of this in CloudFormation, and how hard you thought that was, or if you thought that was easy to do.
I haven't tried it in CloudFormation. I use Terraform too.
Okay.
I don't know there's really that much actual core support in Terraform for it, but I did find a couple people that had written modules that will handle it, and I played around with a little bit. didn't really get it working, but I was just using console. But it looks
Mhm.
like it should be, pretty straightforward coming up once they work out some of the bugs and actually get a good integration with it.
Okay. Yeah. And I'm curious because I've never used EventBridge for what you were actually showing there, which is actually doing like business logic stuff, right? Like actual creating actual workloads. I usually use EventBridge for like operational stuff,
Yeah.
But have you actually used this in like actual workloads that you've actually built and sort of operationalized?
Uh, not in actual production yet.
Oh,
Just
okay.
started getting to it recently, but the one with
Okay.
the VIN number I just showed you, that was
Yeah.
basically taking something I'd written last year, and as a
Oh,
a complex involved Lambda that you had to go out, call it, format it, do all this, and replaced it
uh-huh.
with that. So
Oh,
just in doing this demonstration, code I wrote on one project last year, about 60% of it got kind of replaced with just through EventBridge Pipes.
oh, gotcha. Right. Wow, that's cool. Yeah. Yeah, that's amazing. And yeah, you basically didn't write uh any code there, really.
Yeah.
Um,
Yeah.
right. So that's
I had two
yeah.
Lambda functions just for the demonstration, and all they did was write a record into a Dynamo database or
Oh,
Dynamo
right.
table. And that was it. So everything
Right.
else, yeah, it's all inside of the BitBridge.
Yeah, that's awesome. Yeah, that's super
Yeah,
cool.
this is really, yeah, because this really delivers on the promise of what serverless would eventually become, right? This whole
Yeah.
concept of a lot of very interchangeable Legos, if you will, in
Yeah.
a cloud environment where all these mundane, just brute force code crap that you're doing all the time, that's not really the creative energy of implementing business logic or really functionality, is starting to come into play in these purely serverless native models like this, where now you get to, I mean, it's, you talk about the delta of like 60% there that it reduced of the work and code by just using these highly configurable capabilities in among the variety of AWS serverless services that you used for that. Like that's the part to me that's really neat about this, is having seen this evolution over the last few years of that, the maturity of that tool set now.
Yeah, that is really cool. Yeah, that's amazing. And you can see behind the scenes, Chris, when you were building that, like with the step function stuff, there's a lot of conventional there's a lot of conventions that are being used like in step functions or whatever, where it's behind the scenes creating a whole bunch of you know infrastructure, and it's coding it in effect in step functions, for example. And but because you're kind of going with the conventions throughout this whole process, you you get basically a very, very low code experience, which is like super cool.
Yeah.
Yeah.
Yeah. It reduces the code amount needed by quite a bit
Yeah.
just on integration.
Yeah. And that's why I was kind of curious about the automation of this, because you'd want to you always want to be able to create those CloudFormation Terraform scripts, so that I'll usually create those just after I've gone through the console. I'll kind of go through and create like a CloudFormation script just so I can remember what I did. Right. It's like, because I will have gone through this whole console experience, click ops basically. And then I always want to capture what I did so that I can recreate it in the future, because I'll come back to it a month later and I will not remember what I did. So
Oh yeah, I'm the same way. It's like when
yeah.
I'm developing any service, I write the Terraform code first and build it with that, just because I've been bitten
Oh,
enough times if I don't, that, oh wait, I forgot that's there and I've got to
yeah.
change it. Oh, I'm moving to somewhere else now. So I always do Terraform first. So I looked into
Yeah.
it, and yeah, there's a third-party module I think for it,
Okay.
but I don't think it's an actual core yet.
Gotcha. In CloudFormation, I'm sure that it's all built in already in CloudFormation, but yeah, in Terraform, I could
Yeah.
totally see it's a module. Yeah. So yeah, I'm sitting here thinking of more of lots of applications for this. I think it kind of you could kind of go really far with this. I'm wondering what the kind of trade-off there is in writing full applications with this. You could basically write a full application with this kind of style. But I wonder at a certain point you'll start incurring the kind of cost of the sort of latency as this kind of the latency as opposed to just writing an app that does all that integrated into one thing. I'm trying to think of like the trade-off there, but I don't know. Have you ever thought of that?
Yeah. Yeah. If you're doing like just a big app, yeah, you may have a little bit, the trade-off where it's better just keep a lot of logic in the app. But yeah, if you're going straight up like, event-driven microservices, then you're going to have to be writing a lot of Lambda functions and everything else just for the interaction between all your services. So not only does it save you the code, it also lets you, filter down what you're processing. So you're also saving on compute costs because you're not having to run everything through a Lambda. You just filter it out and then run what you need. So it actually saves you there.
Right. That's true. So I'm wondering if this kind of if this is kind of like a similar similar kind of use case where you would use like an event, like a traditional event bus, like MuleSoft or any of those places like that. This feels different to me, but just curious what you think about that.
Yeah, it's different because it's not really like an event bus because you have the event bus. It's like, oh, this event happened. What do I need to notify? I need to connect. This is more about I need to connect this one thing to this other service, and that's all it's going to do for you.
Right. This is connecting pipes together.
This is just this is not a broad scope. It's a very specific scope of I need this one thing to do this one function and go to this one place.
Right. Whereas, like what you said, MuleSoft is kind of a more broader message bus transformation system. You could use MuleSoft as part of this flow. This is like a bigger a connectivity kind of thing. When it gets into all that, the bigger event buses, one pattern you may want to look at is you have something come in and goes through a pipe. Well, if you're running, you want to hit that to multiple things. So if you need this one event to hit a few things, instead of running multiple pipes, because every pipe's going to consume one read resource on you. So the better practice would be run a pipe, do your filter and transform, and then push that to like an SNS topic, and then fan it out from there. Oh, gotcha. Okay. Yeah, that's a good idea.
Yeah, because they recommend basically if you're going into a certain event, limit it to maybe 2 pipes. If you need more, fan it out.
Oh, okay.
Yeah, because it does consume a read resource.
That's because of cost basically, or consumption?
Because with Dynamo, it's like you got a stream. If you got 5 of these running on one stream, that's more read resources that you've got to utilize and provision out. So it's going to cost you more to run it that way instead of just having one and fan that out to an SNS.
Right. Okay. Yeah, that's cool.
But as far as the pricing goes, it's not bad because one on the back end, it's going to save you on compute time on Lambdas, but actually just running an event, I think it's up since reInvent, but it's only, I think, $1 for 1 million events right now. And any of all those events can have a 64 kilobyte package with it.
So taking this in a use case like what you're doing of a large data batch processing, for example, becomes really economical in terms of speed and cost.
It cuts your implementation time and cost. It cuts your back-end compute costs. So it generally saves you a lot all around on your cost of ownership.